This is the design and construction of a prototype tremolo pedal for the guitar. The circuit schematic is at the end of this video. Thanks. Here's the design of the tremolo pedal. We're going to have a level knob, potentiometer, depth knob, rate knob, an LED to indicate battery on off. That'll probably be moved up here. It's going to be a purely analog signal going from input to output. So we're going to have guitar, and then to prevent the guitar pickups electronics from loading the amplifier, we're going to have a buffer there. And then the amplifier is going to be a voltage controlled amplifier, which will be a JFET controlled by the MSP. So that'll be the control signal using pulse width modulation. And then so that the output electronics don't affect the audio signal, we're going to put a buffer there as well. And for the buffers, you just want to be careful that you're using op amps that are that can be powered by 9 volts. So no plus or minus 9 volt op amps or plus or minus 12. Plus or minus 9 would be a total of 18. We're only going to have 9 for our pedal, and so we want like plus or minus 4.5. We'll establish a virtual ground in between the 0 and 9 volts. And then, so yeah, for our power, we're going to run off a single 9 volt battery. Again, establishing a virtual ground to shift up the audio signal so that we'll have symmetrical power supplies there. And then we do need a linear regulator for the MSP to power it, but with 3.3 volts. So just make sure that you get one that is good for audio, so that none of the digital noise will leak into our audio, our analog signal there. So I fed my design into a generative AI. It gave me a nice bill of materials, various parts, but just again, remember that the op amps should be able to be powered by 9 volts, and your linear regulator needs to be a good one for audio. Using Code Composer Studio, I set up 2 timers that control the pulse width modulation from the MSP430 that's going to feed the voltage controlled amplifier. So one of those timers is controlling the frequency of the pulse width modulated signal. I've got that configured to 20,000 hertz. And the second timer is actually changing, and that's going to change the pulse width in a linear fashion. So I've got my MSP430 here. I've been routing the pulse width modulated signal to P1.3, and I'm using the Analog Discovery to probe that just to make sure that it works correctly. So here's the output of that Analog Discovery. You can see the 20,000 hertz wave there, and you can see the pulse width getting larger there slowly. And then now it's going to get smaller. Nice. And so later, next step, I guess, I'm going to feed this signal to a filter, just a simple RC filter, and that's going to smooth that square wave into a triangle wave, and we'll send that triangle wave to the voltage controlled amplifier. All right, I've got this simple RC filter here connecting to my square pulse width modulated signal, taking the output across the capacitor there. It's a 1 microfarad capacitor, and I also have that 10 kilo ohm resistor there. So that puts the time constant at 10 milliseconds, which is about 16 hertz. So the input to the filter is the MSP pulse width modulated square wave there, and the output gives me a triangle wave. Here's the triangle wave B, and looks like I've got a period of about 2 seconds. So that's directly connected to a parameter in my code. That's the rate parameter in my code. And so I'll connect that later to a potentiometer, and we'll be able to adjust the rate. That's really a slow tremolo as it is. And then I've got a voltage here of about maximum about 1.5, it looks like, 1.63 volts. And then a minimum of about 200 millivolts. And again, that's connected to a depth parameter, and that'll be also able to be changed with a potentiometer. And this triangle wave, again, is going to control a voltage controlled amplifier, which will control the volume of our guitar signal. I've got the rate and the depth potentiometers working. These are pretty standard 20 kilo ohm pots. I'm routing them to pins 9.0 and 9.1 on the MSP, and I've configured them in the software to use those pins as the analog channels. So here is the maximum depth. Looks like I'm getting about 3.1 volts amplitude, and this is the maximum rate as well. Looks like I've got a period of about 0.3 seconds. So 0.3 seconds, 300 milliseconds, that makes sense musically, I think. So I'm just gonna come over here, I'm gonna adjust the rate. I'm gonna just adjust it as much as I can, and then that will adjust the triangle right there. And now I have a period of about 1.94 seconds. So that also makes sense musically. It's a really slow tremolo, but you'll still be able to hear it, I believe. And then, so that's the slowest. Now I'm gonna adjust the depth potentiometer here. It's pretty sensitive. I might go back and change that a little bit. It's pretty sensitive. And if I adjust it all the way, then we really get no or very little tremolo effect there. And the signal is biased or with a DC offset that's in the middle of the range, so that's perfect for the voltage controlled amplifier. All right, I've got the voltage controlled amplifier there. This is the JFET. And I'll put the circuit schematic at the end of this video, but I used a voltage divider on the source to bring up the source to give it some bias, because the gate, as we previously saw, the control voltage had some bias too. So this keeps the gate to source voltage unbiased. I've also got a capacitor there at the output to couple it so that it removes DC as well. And what else I got? Yeah. And I've got a divider on the control voltage as well. So I don't have the audio connected just yet because I don't have the buffers connected just yet. So to simulate a guitar signal, I've got 440 kilohertz. That shouldn't be. Let's go 440 hertz. That's better. So I've got a 440 hertz wave there at 100 millivolts, and that's the input to my voltage controlled amplifier. And I've got the rate at its slowest right now and the depth at its highest, so you can see that. And I'm getting about 100 millivolts out, so a gain of 1. And then I'm just going to increase the rate potentiometer, so we'll see what effect that has. And there you can see the rate. That's lovely, isn't that nice? So the tremolo is working better there, or faster anyway. I'll go back to a slower tremolo. Just decrease the rate. There we go. Okay, and now I'll change the depth knob, so we should see less volume as I change that. Let's see what we get. Yeah. Nice. It's probably too much. I might want to adjust for that as well. It's probably, that won't be audible. I actually decided to change a voltage divider that was biasing the source. I decided to bring up the source voltage and thus decrease the gate to source voltage so that the transistor is not always conducting. And so there's a higher voltage, higher signal when I adjust the depth. So here's the maximum depth. As you can see, there's a lot of warble there. And then if I crank the depth knob to almost 0 depth, you'll see, oh, there's not a lot of warble there. And if I keep going, here's like 0 depth. See what that looks like. It takes some time to adjust. Yeah. So 0 depth looks pretty good. There's 0 depth. Nice. So here we're just getting the sine wave essentially. No warble at all. Nice. Now I've just wired up my input and output buffer from the same chip. There it is right there. That is the op amp TL072CP. It's a great op amp for buffering audio signals, and it's a dual buffer. So I've got both input and output buffered from there. I also wired up the input and the output, although I haven't done the battery circuitry. I don't think I'm going to actually. I'm running out of time, and I'd rather just work on some other projects. So, and I usually just power my pedals with a power block anyway. So I don't have the battery circuitry or the regulator wired up, but I do have the 9 volts going there. I had to put some capacitors at the output to remove the DC bias. Otherwise, the the op amp requires a symmetric power supply. So right now, my signal would be centered at 4.5 volts. So I had to block that DC. That does nothing for us, the 4.5 volts. So I had to block that DC, bring the audio signal back centered at 0. I also do not have the level knob wired up. Again, I think I'm just gonna, at this point, I'm gonna just move on without the level knob. So I do have the rate and the depth working, and I have my guitar and my amp connected, and so let's give it a shot. Nice. And the depth. Yeah, that's awesome. So yeah, maybe in another video then I'll try to minimize this thing and actually get it onto a PCB and then put it into the pedal container and actually use it. Nice.